All right. Hello, and thanks everyone for joining us for another episode of Scoliosis Dialogues. This is a new kind of podcast for SRS. Today, we're going to be introducing a different format. We're going to be bringing you the first in a new series where we interview authors of an upcoming article that's going to be coming out in the Scoliosis Research Society's journal, Spine Deformity. So we'll talk a little bit about the author, figure out what made them do the research, kind of get into their background, and then we'll talk a little bit about the paper as well. So without further ado, I'm going to introduce our guest today, who is Dr. Erin Hannink, and she's the lead author on a study coming out in this November issue of Spine Deformity entitled The Validity of Sagittal Thoracolumbar Curve Measurement Using Non-Radiographic Surface Topography Method. Okay, so welcome, Erin. Maybe I wanted to start a little bit by just having you introduce yourself. Tell us a little bit about yourself. Where do you live and where did you grow up?
Hi, thank you. Yes, I'm currently in Oxford, United Kingdom, but as I was saying earlier, as you can tell from my accent, didn't grow up here. I I grew up in California. I did my undergrad and my Doctor of Physical Therapy programs in Southern California. I worked clinically for a few years, and then I came over to the UK in Oxford, where I've been for 7 or so years. And that's when I started getting into research. So most of my research now is long-term musculoskeletal, specifically around the spine recently.
Yeah, I also, I live in California now, but I grew up in Texas. People often expect me to have an accent when I sign on to the podcast, but no, I've adopted a neutral California English to be better understood by those around me. Cool. So you are not a surgeon, which is wonderful. I think it's really great to have a diverse set of opinions in the journal and on the podcast, so we can get different perspective from different people who take care of patients with scoliosis. So, tell me, are you entirely research, or what is your breakdown of research and clinical care?
So over the last, I guess, 7 years, it's tended more towards research. So now the definitely more than 75% research, and I'm a physical therapist or physiotherapist, but with general musculoskeletal. So I wasn't specializing in spine deformity or scoliosis, but I definitely had those patients in my practice.
Sounds good. And so we have a lot of different listeners. We have surgeons and non-surgeon providers who care for patients with scoliosis. We also have a lot of patients who listen to the podcast too. So tell me a bit about what your day is like in your current job.
Okay, day in the life. So right now I'm doing quite a bit more work, not non-patient facing, unfortunately, just because of COVID. So this latest study that I'll be talking about, it was cut off, and there were lots of restrictions, and I work in the NHS, so most of the non-essential, non-COVID research had to be stopped. So since then, we're just starting to pick up on research. I will see and assess people in some of the research studies that we have going on in our group. But I'm kind of dug into the research, doing a few systematic reviews at the moment.
Yeah, people are often surprised how much of research means me sitting in front of a computer staring at it.
Yeah, exactly.
There's exciting parts too. Not that isn't exciting.
It is. It is more exciting to see patients and see participants. Absolutely.
Yeah. Well, we hope you get back there soon.
Yeah.
Cool. So your current paper is about surface topography for quantifying spinal curvature. So tell me how you got interested in that topic.
Yeah. So this is part of my PhD research, and originally I wanted to look at people just in the sagittal plane. So mostly people with osteoporosis. That's how it got started with the PROVE study that we had going on in our group. We looked at different, presentations of a kyphotic spine, essentially, and we wanted to look a little bit deeper into, why is the apex here or why is the apex lower? So I was looking for a tool that would be able to be kind of affordable and portable. And it led me to using the Kinect sensor as a surface topography measure. I actually collaborated with Tom Shannon, who is the founder of Vicon, and he had been working on a program using the Kinect sensor with a particularly severe scoliosis population in Bulgaria. And so he was looking at the cosmetic defect, so kind of the asymmetries in the surface topography of the back. I worked with him to use it to look specifically at the sagittal plane. And so that's how I chose the Microsoft Kinect. And another thing that's interesting about the Kinect here is that normally people think about it as gaming, but it has lots of uses in healthcare for different imaging. And this second generation uses time of flight, which is kind of a complicated new technology, but it is an advancement from, I don't know if you're familiar with, some people might be familiar with like raster stereography and different triangulation methods to kind of get a map of the back. This one is more similar to what our phones are using and kind of the next step. So that's what's particularly exciting about this method.
Okay. Yeah, I did. I Googled your sensor before we got on. It sounds like its primary commercial use is in association with an Xbox. Is that right?
Xbox. Yeah, exactly. But you'll see tons of literature actually. And so that there's a first generation. This one is the second generation. Again, it's affordable because it was for mainstream gamers, I guess. But the third generation, this next generation, is geared towards research because they saw all the research happening, and it's called the Kinect Azure, and it also is connected with the Microsoft Cloud, and kind of that's the step that it's going towards.
Sounds good. And so just for disclosure purposes, do you have any company connections to Microsoft or Xbox or anything like that? We're talking about a lot of brand names.
Right. No, not at all. It was just because it was an affordable piece of equipment that had a lot of punch for what you could get essentially. And I think that's why it was 130 pounds, so probably $150. So when you're talking about medical devices, that's very cheap. You have to use it with the laptop, but again, kind of the advancement, you would think that it could lead to using it on like a mobile device.
Yeah. So for disclosure purposes, I am involved in research in 3D surface topography measurement too, but we're not going to be talking about my device today. We're going to focus on yours.
Okay. Maybe a later episode we can compare and contrast.
We'll see. Yeah. Great. So tell me like how much time it takes to perform these measurements in the clinic. Is this something that you could work into like a regular workflow of seeing patients?
Yeah, so that is one of the challenges. It's portable, but the way that we were using it, you need a laptop, so you need to plug it in. So it's not like you can't bring it anywhere really quickly, but compared to some of the other surface topography methods, it's more portable. It's not as portable as, say, the inclinometer and the flexicurve, which is what I compared it against. The clinical, flexicurve is a flexible ruler that you can kind of curl up into a little ball. The inclinometers are also small and handheld. So compared to those, not as portable and not as clinically easy, but it's somewhere in between, I would say. And then in terms of how long it takes, patient facing, very quick. You can press a couple buttons. The analysis on the back end is a little bit more time consuming than for example, just getting an angle off of an inclinometer. But that's another thing that could be streamlined and made a little bit easier when it's not in a research project.
Okay. And so just to kind of give our listeners a summary of the article. So you had a population of patients that you had x-rays on, and then in a separate setting, you took some measurements with these 3 different devices, and you tried to quantify their kyphosis, their thoracic kyphosis and their lumbar lordosis, right? And then compared those measurements. Is that it in a nutshell?
Perfect. Yes, that's it in a
Great.
nutshell. Yep.
And so summarize what you found for the listeners
Yeah.
comparing these devices.
So essentially it was in the thoracic spine, or more specifically when you're measuring kyphosis, it has really good correlation with the x-ray, and all three methods have good correlation with each other. But when you move down into the lumbar spine, and again, specifically lordosis, it's a different story. So all of the surface measurements, they're essentially measuring the same thing, the surface, and they correlate well with each other. But none of the surface measurements, including the connect, showed validity and correlated with the x-ray. But if you look at what you're measuring with the x-ray, and we chose the Cobb angle just because it's the most widely used, you're really measuring different things. And if you look at the anatomy and the soft tissue structures over it, you can see why you're not getting a correlation, essentially.
And so the process for doing the surface topography, you had to actually place markers on the patient ahead of time. Is that right?
Yes. So I placed markers on C7 and his dimples of Venus, or L2 region. And I also did L1 because I wanted to know specifically where L1 was. Another way you could do it is just getting from the top and the bottom and drawing that line from C7 to S2.
Okay. And do you think that placing, so summarize maybe what you think are the issues with why it didn't work so well in the lumbar spine?
So I don't think, I think it was on par with most of the surface methods in the lumbar spine. When you get more lordosis, you're kind of compressing that area, and you get more, soft tissue. Or if there is adipose tissue, you're going to get a different distribution, as opposed to when you are in a kyphotic posture where the spinous processes are closer to the surface. And again, the Cobb angle, we're measuring, the orientation of one vertebrae and then the other at the bottom of that region. And so there's a lot of information missing in between. So I think that's where the disconnect comes from.
Yeah, there's just a lot more in between you and the spine, I guess, huh?
Yeah, there is more. Yeah.
Cool. All right. So where do you see this going now? What do you think the next steps are?
Yeah, I think it's just a step. I mentioned a bit in the beginning, a step towards possibly getting it in an actual mobile device, because the time of flight technology is being used in some phones and some actually very small portable devices. This method could kind of be used there. There's also a lot of research going on with markerless anatomical markers, which in the spine is more difficult than kind of a joint like an elbow or a knee. But again, with AI, when you get enough input in, that's definitely a possibility.
Yeah. Yeah, well, I think it's a really exciting field, obviously, because I'm working in it too. But we make so many assessments of the sagittal plane on X-ray, and it's just one moment in time, and we take one X-ray. But with surface topography measurements, you can take a lot of them over 10 days and make an average, to kind of understand where somebody sits on average over a given period of time, as opposed to just one awkward stance in the X-ray.
Absolutely. I think that's definitely one of the big benefits to surface topography, and kind of some of these movement devices where you can get multiple readings, and exactly what you're saying, John.
Yeah. So what do you think are the main clinical applications of this?
So unfortunately, this isn't one that can go straight into the clinic. I mentioned it is kind of a research software program, but one thing that you can see is that these surface topography methods and all the other surface methods are really good for kyphosis. So when you are measuring thoracic spine or kyphosis, there's a big overlap in between. We're going to get pretty accurate measurements compared to an X-ray. But looking at surface measurements, and the lumbar spine is a completely different story. So I don't think they are this method and many others are valid to look in the lumbar region.
Yeah, some more work to be done there for sure. Great. Okay. Well, I guess one other question I had for you was you looked at it across a bunch of different patients, right? So some of the patients had surgery, some of the patients had scoliosis, some of the patients didn't have either of those things. Did you find that it was any better or any worse for any given population?
Yeah, so that's it was a benefit and a drawback. There was another study that was done by Queck et al., and they looked at very healthy people, 20, 30s, healthy backs. And so I did want to see a more clinical population, but then when you get so much diversity, we need a bigger sample size. But what I did notice, and this isn't reported specifically in the paper though, that some of the patients with lumbar spinal stenosis, so they're starting to flatten in the lumbar spine, and again, some of them were even more kyphotic in the lumbar spine. You're getting more accurate. So that's why I made that distinction between lumbar spine and kyphosis versus, specifically the lumbar spine lordosis.
Great. Yeah. Well, we're all interested in the next installment of your research and more research in this field. I know, a lot of my patients are super excited about the possibility of this, so we can start getting some numbers to describe what's going on in their back without irradiating them, and also to have something that maybe they can use, at home in the future to quantify what's going on without having to come into the office.
Yeah, I agree. And I think actually one thing that people really liked was kind of with the surface topography, our output was kind of like a heat map looking, I guess what you would see on any surface topography map. And that was really nice for patients to see. They like that. So kind of seeing a good visualization of their back. Some people really did like that. Cool.
All right. Well, thanks for joining us today. I think this is a great kickoff to this new episode format. And I hope our listeners will stay tuned for the next one.
Thanks for having me. This is fun.
The Scoliosis Research Society is a nonprofit professional organization made up of physicians and allied health personnel. Their primary focus is on providing continuing medical education for healthcare professionals and on funding and supporting research in spinal deformities. Please visit srs.org for further information.